In this video, we'll be learning about Soh-Cah-Toa, and more than anything else, this is really just a method for memorizing the different trigonometric ratios. So let's say we're given this right angle triangle that we see here, and that we're considering the interior angle A, which I'm just writing there. Now, as we've seen before, relative to that angle A, we have an opposite side, which I'll just write as opposite here. OPP. We have an adjacent side length, which I'll write as ADJ, next to the A. Remember, adjacent means next to, and it's a side length which actually touches the angle A. And of course, since it's a right angle triangle, we have this other side length, which is directly opposite the right angle, which is the hypotenuse, which I'll just write as hyp. Now, the trigonometric ratios for this angle A, as you probably know, would be sine of A, which we write sin A, and that is equal to the opposite side length divided by the hypotenuse. Similarly, we have the cosine of that angle A, which is equal to the adjacent side length divided by the hypotenuse. And finally, we have the tangent of that angle A, which is defined as the opposite side length, opposite to A that is, divided by the adjacent side length. Now, here's a nice little trick to memorize these. We're going to write the word Soh-Cah-Toa, which I'm writing here. S-O-H, so, Ka, C-A-H, Toa, T-O-A. And here's how this works. I'm going to focus, I'll start with the first one here, the first three-letter word, looking at so. So stands for, the S stands for sine, the O stands for opposite, and the H stands for hypotenuse. And what this tells us is that for any angle, which we'll stick to the letter A for now, sine A is equal to O divided by H. In other words, what we're doing here is that we're taking any triangle, right angle triangle I should say, with a right angle here, and we're saying that relative to A, instead of calling the opposite side length OPP or even opposite, we're just going to go ahead and call it O. The hypotenuse, we're simply calling it H, and so tells us that sine of A is equal to opposite divided by hypotenuse. So what this is telling us is that the first letter here, this first letter, S, is the trigonometric ratio. The second letter, which in this case is O, tells us the side length which is on the numerator, and the third letter is the side length which goes on the denominator. So when I read so, I know that sine is equal to opposite over hypotenuse. In a similar way, if we look at Ka, the C in this case stands for cosine. The capital A stands for adjacent, and the capital H, again, just as before, stands for hypotenuse. And so reading this, when I look at Ka, the first letter is cosine, and that is equal to the second letter divided by the third letter. In other words, cosine is equal to adjacent divided by hypotenuse. So if I draw a right angle triangle here, the cosine of this angle A is equal to the adjacent divided by the hypotenuse. And that's cosine of A is equal to A over H. Last but not least, when we read Toa, the T here stands for tangent. The O stands for opposite, and the A stands for adjacent. So, once again, referring to our right angle triangle, and if I consider this angle A, the tangent of A is equal to O, so the opposite, divided by A, the adjacent. And we write this tan of A equals to O over A. And there we go. Remember, so means sine of an angle equals to opposite over h. Ca, C-A-H, means that the cosine of an angle A is equal to adjacent over hypotenuse. And toa of an angle means that tan of an angle A is equal to opposite over adjacent. Putting these all together leads us to Soh-Cah-Toa. And that's it.